Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So today's challenge is a really simple one, I think. So you should definitely try this on your own first and then continue watching with the video. So you need to find the minimum area to cover all the ones. So you are given a 2D binary array grid. Find a rectangle with horizontal and vertical lines with the smallest area such that all the ones in the grid lie inside this rectangle and return the minimum possible area of that rectangle. So you need to find one rectangle such that it covers all of the ones in the grid, but the rectangle itself may not consist of only ones. It can consist of both ones and zeros, but it should make sure that it is covering all of the ones which are in the grid. Okay, so if I tell you, like, test cases are not that much good right here. So if I give you some interesting test cases, like let's say this one. Mm, let's say something like this is there, uh, and something like this is also there, and here is a one here. Okay, and you get some things like this. You have a lot of zeros in the left, and to the right maybe you have this one. And okay, so yeah, that, let's say another row of zeros you have. So let's say you are given this grid. Okay, you are given this grid in your test case, and you want to find which is the largest possible, which is the smallest possible rectangle which covers all the ones. Okay, so what do you need to do is that you just try to draw one rectangle that will cover all of the ones in the grid. Okay, so you see, if you try to draw some rectangle like this, it will cover all the ones in the grid. Okay, so you see, this one, this thing, this, all of this is covered by this rectangle, and you need to find the minimum possible rectangle. Why do they ask for the minimum rectangle? Because even if you draw your rectangle a little bit bigger, it still covers all the ones, right? If you, even if you draw your rectangle the whole square, the whole matrix, it still covers all the ones, but you need the minimum possible ones which is actually covering. Okay, so I hope you get it. And if you try to cut down your answer to a little bit smaller rectangle, if you try to see, if you try to cover this thing, then you will be missing out on this one. Okay, so you cannot reduce it. So one thing you can do easily, one intuition you can get very easily is that uh, everyone should be included in the rectangle, and therefore let's say the bounds of the, let's say these two are the bounds of the uh, breadth of the rectangle. Okay, and these two are the lengths of bounds of the length of the rectangle. So if this dimension is let's say n, and I iterate it using the j variable, and let's say this dimension is m, and I iterate it using the I variable. Okay, so you already know how to iterate through a 2D matrix, right? That's very simple. So if so, you see, as you go to a 1, you update your minimum and maximum values of I and j. So you see, this is nothing but your minimum minimum value of I. Okay, uh, in this bound, when you are here, you are nothing at your minimum value of I, and you are this, you are in the maximum value of I. Okay, so this is the upper bound of I, because what is the value of I here? It's 0, 1, 2, 3, 4. I is 4, and here I is 1, you see. And what is the length of the what is the breadth of this rectangle? The area is nothing, or you need to find the area, which is nothing but length into breadth, right? So this breadth, the length of this breadth is nothing but 4 minus 1 plus 1, which is 4. How do I get it? Because you see, the length is 4, so 4 minus 1 is 3. You just add 1, so it will be, the breadth will be nothing but max I minus min I and plus 1. This is the breadth. And in a similar manner, you can get the length also. Okay, you can take this as minimum j, you can take this as maximum j, and what you can do next is that you can write that my length is nothing but maximum j minus minimum j plus 1. Okay, So after writing the length and the breadth, you can just find the area. You can just return length into breadth. Okay, so length into breadth. So I hope this is very simple and easy to understand it. Okay, so that's all you need to do for this problem. That's all you need to think. So in order, whenever you get a 1, you just update your 4 variables. You keep 4 of your variables. Okay, what are those 4 variables? It will be min j, max j, min I, and max I. With these variables, you will get to calculate your length and breadth of the smallest possible rectangle, and with that length and breadth, you can easily obtain your area. Okay, and there should be no difficulty in that. And I hope this is clear to you. Okay, so this problem is very simple. You can easily solve it in O of n square complexity. Okay, so if you try to solve it right now, it will be something like m. Let's take the dimension of m to be grid dot size, and let's take that I will iterate through this particular dimension and j will iterate through this particular dimension. So the second dimension is nothing but grid of 0 dot size, and as I told you, you need 4 variables, right? So what are those variables? Min I. Okay, uh, min I should be initialized with the maximum value. Since I is iterating through the dimension of m, the maximum value it can go is m minus 1. And you know that while calculating minimum, you need to initialize by maximum value, and while calculating maximum, you need to initialize by minimum value. So those things I think is very simple to understand. And yeah, so you have a min j as well as your max j, and so yeah, you have it. And now you just iterate through the whole grid. Okay, so I think this is very simple. So you just keep m to iterate through the I, as I had taken this convention, and you just keep j to iterate through your n. Okay, you have your I and j right now, and what you can do is that it's very simple. If you see your grid of ij is 1, so you need to cover this particular one, right? So if you want to cover this particular one, then definitely you need to update your bounds. You need to make sure that this one is lying within your rectangle, and therefore you will update all possible minimum values, maximum values, and everything. Okay, and everything. So you see maximum I is nothing but max of max I, and I. Okay, so you do the same thing for j. You do the exact same thing for j. So yeah, you have it, and you just change all the i's to j's. Okay, so you can just press alt and do that to take all the i's and convert it into j. So yeah, so you have it. And now it's very simple. You see, you know the length and breadth. So what is the length right now? Length will be uh, is along the j, so it's nothing but max j minus min j plus 1, and breadth is nothing but max I minus min I plus 1. So as I had already told you here, what are the length and the breadth values, and all you need to do is return length into breadth, and I hope that will be very simple and easy to understand. Okay, there should be no difficulty. So let's try to run and check if it works. You see, we got an accepted case. Let's try to submit it and check if we get an accepted case, or is there any error. So you see, there is no error. Okay, and this same solution was giving me around 60% runtime bits, and it is right now giving me 21% bits only. So yeah, you see there is a lot of variation. It was memory is now suddenly 87%. So yeah, that's not the problem, I think, because if you are given a 2D binary array, you at least need to do it in O of m into n. Okay, you cannot do better than this. Okay, and there is no significant space complexity also, because I am not using any extra vector or extra matrices. So I think this will be the most optimal one. So yeah, that's all. I guess that's all for this video. I guess this was a quite simple one for you to understand. And yeah, I hope your day also goes as easy as the problem. Thank you so much. I will meet you in the next video.